Okay, so guys, today I'm going to read Experiments with Water by Salvatore Tosi. But before I read the book, like and subscribe. Will Pill see his shadow? Have you ever heard of Paxosuri Pill? I can't pronounce that, although you may never have heard of him. Pill is very famous. Every year on February 2, people gather in a little town in Pennsylvania called Puxatawney. They wait for Pill to come out of his home. Pill's not a person. He is a groundhog, which is a small animal that lives underground. According to legend, if Pill comes out of this hole and she is shadow, there will be another 6 weeks of winter. If he does not see his shadow, Satan will arrive. This legend will become so popular that February 2 is known throughout the United States as Groundhog Day. Forecasting the weather based on what Pill is not significant. However, weather forecasting is actually very scientific. For example, satellites in orbit continuously transmit information about weather conditions. Planes fly into hurricanes to obtain information that scientists use to determine where the storm is likely to head. Eventually, you do not need a satellite or plane to learn more about the weather. All you need is to perform the experiment in this book. What is the weather? Earth's weather takes place within 7 miles, 11 kilometers of its surface. The region above Earth's surface is known as the atmosphere. The weather is a description of the conditions that exist in the atmosphere. Looking up at the sky, you can give you the impression that the only things you can find in these weather conditions can be described as a warm day with mostly sunny skies. Let's get back to reading. The atmosphere are clouds, but the atmosphere is actually filled with invisible gases, such as oxygen and carbon dioxide. This mixture of gases is called air. Is there some way to prove that there's really something in air even though you cannot see it? Okay, taking out space. You will need deep bowl, small cork, clear drinking glass. Okay. You might not really see it. Okay, fill the bowl about halfway with water. Place the cork on the water. You may not really see it. And what is this? You guys, you may have a hard time seeing this words because this book, I don't know what happened. Okay, let's just continue to read. Hold the glass upside down over cork. Slowly push the glass down into the water. What happens to the cork? The water and cork inside glass are forced down below the level of the water in the bowl. The glass will really empty. Okay. The water and cork inside the glass will be at the same level as the water in the bowl. Although it looks empty, the glass is actually filled with water. This air takes up space and prevents the water in the bowl from filling the glass. The air inside the glass bowl keeps the water in the bowl free from filling the glass. The sun has a tremendous influence on our water. The air in the atmosphere is warmed by the sun, which causes hot summer days. What else happens as air is warmed by the sun? Experiment number 2. Rising up. You will need pencil, tissue paper, scissors, ruler, thread, transparent tape, lamp. Carefully draw a spiral pattern on the tissue paper. Color along the line. Now cut a 6-inch, 15 centimeter piece of thread. Tape one end of the thread to the center of the paper spiral. Remove the lamp and lamp shade and turn on the light. Hold the free end of the thread so that the paper spiral is about 3 inches, 7.5 centimeters above the light bulb. Watch what happens to the paper spiral after a few minutes. Draw the spiral so that it measures 3 inches, 7.5 centimeters in diameter across the tissue paper and then cut along the line. Heat from the light bulb warms the air above it. As the air gets warmer, it rises. Cooler air moves downward to take the place of the warmer rising air. This warming of air causes the paper spiral to twirl. As long as the light is on, the heat will continue to make the air above it rise. The air near the ground may be warm. However, the air near the top of mountains may be cold enough for snow to cover the peaks. Heat from the sun warms the air atmosphere, causing it to rise. If warm air rises, why is the weather always cooler at the top of a mountain? Experiment number 3. Expanding and cooling. You will need marker, ruler, an empty plastic milk container with lid, helper, small pot or kettle, stove, oven mitt, hot plate. Draw a line under milk container about 1 inch, 2.5 centimeters from the bottom. Ask an adult to boil some water and then carefully pour it into the container up to the line. Have the adult put on the oven mitt and cover the container. Then ask the adult to quickly shake the container a few times and place it on the hot plate. Watch what happens to the container. The hot water warms the air inside the container. When air is warmed, it not only rises but also spreads out as the warm air inside the container expands and pushes against the sides. This expanding air causes the container to swell up like a barrel. When air is heated by the sun, it rises and starts to expand. As the air spreads out, it also begins to cool. The air continues to expand and cool as it rises up a mountain. By the time it reaches the top, the air has expanded and cooled quite a bit since it rose from the ground. This is why the weather is always cool at the top of the mountain. I meant mountain, sorry. Can you feel the breeze? If you have ever sat on a bench during the summer, you have probably felt a breeze blowing in from the water. This sea breeze is caused by air that moves from the water toward the land. What causes the sea breeze that can keep you cool on a hot summer day? Experiment number 4, heating the air. You will need ruler, marker, large glasses, 2 thermometers, table, desk lamp, clock, pen, paper, pencil. Draw a line 2 inches, 5 centimeters from the bottom of each glass. Pour water into one glass up to the line. Pour dirt into the second glass up to the line. Place a thermometer in each glass. Place the glasses on the table near the top lamp. After 30 minutes, write down the temperatures of the dirt and water. Make sure that the two glasses are the same distance from the lamp. Turn on the lamp. Record the temperature on on each thermometer every 15 minutes for 1 hour. Then turn off the lamp. Again, record the temperatures every 15 minutes for 1 hour. Compare how the temperatures of the dirt and water change in time. You should find that when the light is on, the temperature of the dirt rises faster than the temperature of the water. The difference in time it takes for water and land to change temperature creates both sea and land breeze. So look at this. After the lamp is turned off, the temperature of the dirt drops faster than the temperature of the water. A land such as a bench heats up faster than a large body of water, such as in, be quiet. I'm sorry guys. Such as an ocean does. The warmer air over land rises and is replaced by the cooler air from over water. This creates a sea breeze during the day. At night, the beach cools faster than the ocean. This creates a land breeze at night. When the air moves slowly, you feel a breeze. If the air begins to move more quickly, you feel the wind. How can you measure how fast the air is moving? Experiment number 5. Blowing in the wind. You will need pencil with an eraser, ruler, piece of stiff cloth, board at least 4 inches by 12 inches, 10 centimeters by 20 centimeters, scissors, staple, marker, 4 small paper cups, pushpin, modeling clay, salad optional. Watch that measures seconds. Helper. Draw 2 rectangles on the cardboard. Each rectangle should measure 2 inches, 5 centimeters wide and 12 inches, 50 centimeters long. Cut out both rectangles cross. You may not really see it, but I can still read it. The cardboard strips to make a plus sign and staple them. Use the water to draw 2 lines, one each from each opposite corners, where the 2 strips cross each other to the opposite corners. This point where these 2 lines cross is the center of the plus sign is made by the strips. Use the marker to color the outside of one of the paper cups. Staple the cups to the ends of the cardboard strips. Make sure that all the cups face the same direction. Push the pen through the center of the strips and into the eraser. Take everything outside. Place a small lump of modeling clay on a flat surface such as tree, stump, fence rail, or the top step of a ladder. Stick the sharpened point of the pencil into the clay so that it stands up straight. As the wind blows, count the number of times the colored cup spins past in 1 minute. Have you a helper keep track of the time? The instrument you have made to measure wind speed is called an anemometer. Your anemometer measures wind speed in revolution spins per minute. Try measuring wind speed at different locations and different times of the day. How do your wind speed compare? Weather forecasters use anemometers that measure wind speed in miles per hour or kilometers in miles per hour or kilometers per hour. They also use a device that measures how much moisture or humidity is in the air. Humidity is reported as a percentage. For example, the humidity in the Morgan summer day may be 90%. This means that the air is holding 90% of all the moisture it can. Learn how you can use 2 thermometers or tell if the humidity is low or high. Experiment number 6. Checking the humidity. You will need cotton ball, 2 thermometers, table, fan, chalk, pencil, paper, Wet the cotton ball with water and place it over the bulb. Oh my gosh, this is so long. We might finish this in 20 or 30 minutes. Of one of the thermometers, place both thermometers on the table. Set the fan so that it will blow on the bulbs of both thermometers. Turn on the fan. After 10 minutes, turn off the fan. Record the temperature on both thermometers. Do this experiment twice, once on a cool, sunny day and again on a rainy day. The thermometer was covered with a moist cotton bud should show a lower temperature. Subtract the temperature reading on this temperature from the reading on the other temperature. Oh, sorry. How does the difference between the two readings you get on a sunny day compared to with the difference you get on a rainy day? Make sure that the two thermometers are the same distance from the fan. Humidity in the atmosphere is measured with a hydrometer. The humidity the air is measured with a device called a hydrometer. A hydrometer contains two thermometers. One is called a dry bulb thermometer, which is a regular thermometer. The other one is called a wet bulb thermometer. Your wet bulb thermometer cools as water evaporates from the cotton ball. The faster the water evaporates, the lower the temperature gets on this thermometer. Cool sunny days usually have low humidity, which means that the air is dry. On these days, the water on the cotton ball evaporates quickly and cools under the thermometer. As a result, there is a large drop in the temperature. You should see a large difference in the temperature readings between the two thermometers on days with low humidity. The difference in temperature readings between these two thermometers is 25 degrees. This large difference includes low humidity. Oh my gosh, this is so long. I may need help. The difference in temperature readings between these two thermometers is 5 degrees. This small difference includes high humidity. Mommy, can you help me reading this? This is so long.
Okay, I'll help you.
Rainy days have high humidity, which means that the air holds a lot of moisture. On these days, the water on the cotton ball evaporates slowly, and there will be a lot of I can't even read this. Drop. Whoa, this is blurry. In temperature, you should see a small difference in the temperature readings between the two thermometers on days with high humidity. If the humidity is very high, a storm may be coming. Is a storm coming? What the forecasters often report the barometric pressure and tell whether if it's flowing or rising or falling. A barometer is an instrument that measures air pressure. The gases in the air are always moving and bouncing into objects. When they bounce into something such as your skin, they push or press against it. This creates air pressure. Mommy, help me reading. This is so long that my vocal cords can't handle it.
Yeah, I'll read it. Where do you want me to read?
This one.
Okay. You do not feel the air pressure pushing in on you because the air inside you is pushing out with the same force. In this case, the air pressure inside your body equals the air pressure outside your body. See how you can tell when the air pressure around you is changing.
Air pressure is measured with a barometer, with this.
Checking the pressure. Stretch the plastic wrap over the top of the can. Hold the wrap in place with a rubber band. Push the pin through the end of the straw. Place the straw on the plastic wrap so that the 1/3 of it sticks out past the edge of the can. Tape the straw to the can. Stand a ruler and thermometer upright and tape them to a wall. Place the can on the table so that the pin points to the ruler. Record the number on the ruler at which the needle is pointing. Also, record the temperature and the weather conditions.
You will need plastic bag, empty coffee can, rubber band, straight pen, short tape, ruler, thermometer, table, pencil, paper. Do not place your barometer near a window because changes in temperature can also affect it. Check your barometer several times again per week. Make sure to take your readings on the rule only after temperature is. It's the same as it was when you set up your barometer this way. The only thing that can cause the needle to move is a change in the air pressure and not a change in temperature. And which kind of weather does the barometer rise? What does the barometer indicate about the weather? Mommy, help me with this.
On a rainy day, a rising barometer indicates that fair weather is on the way. On a sunny day, a falling barometer indicates that the air pressure is dropping. A low barometric pressure is a sign that a storm is approaching. Perhaps a storm never developed when you were taking your barometer readings. If not, here's your chance to make your own stormy weather.
Okay, Mommy, you can leave. You can leave.
Making clouds. Pour 1/3 cup of warm water into the bottle. Cap the bottle tightly. Shake the bottle for 30 seconds and then place it on the table. Squeeze and then release the bottle several times. Remove the cap. Ask an adult to light a match and hold it over the mouth of the bottle. Quickly squeeze the bottle to put out the match. Then slowly release the bottle so that the smoke is drawn into the bottle. Quickly replace the cap and tighten it. Watch what happens inside the bottle. A cloud forms inside the bottle. This cloud is formed by tiny water droplets that cling to the particles of smoke from the match.
Wait. Okay. You will need a measuring cup, large clear plastic bottle with cap, table, adult helper, match. Okay, guys, so you have to read the rest of the book on your own because, guys, my hand is getting really tired from I'm holding this camera. So, guys, I'm gonna read the rest on my own in my head. You guys read the rest. Guys, pause the video because I'm going a bit fast. Okay, guys, I hope you enjoyed today's video and I'll see you. So thanks for watching. Bye. Shh.